Welcome to the demonstration of OpenL Tablets Tables. We'll be discussing how to develop a table using the OpenL syntax and viewing demonstrations through WebStudio. If you've not viewed the WebStudio Basics video yet, you should do that prior to reviewing this video. Now we're going to review a very important type of table, which is called the spreadsheet table. In OpenL tablets, this is actually similar to an Excel spreadsheet. You have your rows, your columns, your formulas, and calculations as content. You can create calculations in spreadsheets just as you create formulas in Excel. OpenL tables or rules are used as Excel functions inside of these formulas. And actually, there are two types of spreadsheet tables that you can design. The first one is called spreadsheet result, and what it does is it executes all the calculations and formulas in a top-down approach, and then it becomes this results matrix which you can access all of the values that have resolved and reference them from anywhere in your project. Then we have the spreadsheet table that is a type of data type which will actually return one value. The value is calculated by starting from the return row and then only executing the cells that it needs to figure out what the return result is. So in the spreadsheet result type, we had this top-down approach that OpenL was doing processing in. But when we're figuring out just a return value, OpenL is going to look at the return value and then see all the different cells needed and data that it needs in order to calculate that return, and it's only going to execute those. So with like other tables, with your spreadsheet table, you can pass parameters into the spreadsheet table. Also, you can call other OpenL tablets functions. We have some predefined functions that you can use. You can call other decision tables or other executable tables that you've created in your project. But also you can reference other cells inside of this spreadsheet table as well using the syntax $, and whatever the column name and then $ row name, or you could just use $ and the name of the value. So there's a way to reference the data inside of a spreadsheet after it actually calculates. So now we're going to review an example of a spreadsheet table that is of type spreadsheet result table. So this is going to become a matrix of values that are calculated and those values can be retrieved and accessed other places in your module. So let's look at this table. It starts with spreadsheet keyword, and then you have the syntax spreadsheet result, which defines to OpenL what type of spreadsheet table this is, and then you have the name of the table and then any parameters that you're passing in. In this example, we're not passing in any parameters. But then we have the first column where we are actually defining the name that the value of your formula will have. So you can actually use this name in any subsequent formulas that you write. You may then use other columns in rows to define values that you might want to use in your spreadsheet, but you're going to have then a formula cell, which is defined by using a single quote and an equal sign, and then you're going to write your formula or your calculation. It is extremely important that you use the single quote and the equal sign when you're in Excel, because if you just used the equal sign, Excel is going to try to resolve your formula. It is the quote and the equal sign that's going to allow your worksheet to be used with OpenL. When OpenL takes your worksheet, it's going to know where your formula is because it'll have that quote and the equal sign in the whole formula. So that's very important to understand. When you write your formula, you can use any of the predefined functions that OpenL has, and you can view them in the documentation. There's rounding functions and sum functions and functions that you might find in Excel or basic mathematical programs. Also, you can use the $ to reference different cells in your spreadsheet. You can use any mathematical operators. So let's look at this first formula, and really what you should be seeing here, or what you would type in, is the syntax single quote equal sign, and then we are using a predefined function called round. And you should be used to round from Excel or some other type of application. Round is just going to take whatever the value is and round it however it's defined, whether it's rounding up or rounding down. You would have to look at the documentation for OpenL to see exactly how this rounding functionality works. But you'll see that in the parentheses are the parameters that are going to be calculated, where you see the $ amount and the $ exchange rate. OpenL knows to look in that row for a column and a cell underneath of it in its own row that's for amount and for exchange rate. So what it's going to do, it's going to take the amount, which is 10,000, and the exchange rate, which is 1. It is going to multiply those two together, and then it's going to perform any rounding that is required. And now the value of USD is whatever that calculation has equal to, which is 10,000. So further in this example, OpenL will then go to the next row for the euro asset. It's going to perform the formula that we just talked about, and it's going to then take that value, and that will be the value for the euro, and it'll go through the different assets. But then lastly, it's going to get to the last row, which is total, and it's going to perform a different function, the sum function. And using the syntax colon, you're going to then define a range which you're going to sum, and the range that you're going to sum is from your USD to your GLD. So those are the only two references you need to put in here, because we have this range syntax that we can use, which is that 2 colons, and it's going to sum all of these values, which are the values that got calculated. So now you see how writing formulas in OpenL is very similar to how they're written in Excel, except you need to know the OpenL syntax. So here's some syntax that you need to know when writing formulas and calculations in your spreadsheet type of table. The value of a cell can be referenced in another cell by using its column and row names and using the syntax of the $sign. Also, the row or column name can be omitted if you're using the same corresponding row like you just saw on the previous slide. So also, you can call another decision table or whatever executable table that you make by writing the name of that table in your calculation. You can use any of the predefined functions, and you saw that we use sum and round. You can use any mathematical operation, and you can also use the business expression language, which is discussed in the reference material. So, and then down in this table is some syntax you really need to know. The single quote and equal sign is how you're going to define what the formula is, or where OpenL should expect the formula. There is an alternative if you don't like that syntax, where you can just put parentheses around your formula. So also, we've talked about the $sign. You're going to use that to reference values in other cells. The word return is used by the spreadsheet table to identify the value that's going to be returned. And then also we saw was the colon, which you can use for ranges. Now we're going to do a demonstration of spreadsheet tables. I'm in the tutorial project 6, which is for spreadsheet tables. I'm going to open up and view what is in this module. You see that we have some expandable folders. We have one for decision tables, and then we have another one for spreadsheet tables that's in this module. We're going to view both the spreadsheet result table type and a spreadsheet table that returns a value. First, let's look at the spreadsheet result. If I go into the table called Total Assets, you'll see that this spreadsheet table is of type Spreadsheet Result. So all of these rows will execute, as well as any formulas will also resolve, and processing will occur just like you're used to in Microsoft Excel. And the formula in this last USD value column will actually calculate. You can see I have the equal sign, and then I have a function round, and then I have a $ amount, which means it's going to use the amount in this row, and then I'm going to multiply it by an exchange rate, and we see the $ syntax again, and that's going to be the exchange rate in this row. So I'm actually going to run this so you can see it execute, and also notice that there's going to be a sum, which is a range of cells that's going to calculate as well. So I select run, and OpenL then performs all of the calculations in this last column for each row. So then you could reference any of these values that you wanted to from a different table. But now what we're going to do is we're going to look at a spreadsheet that actually returns a value. So we're going to look in the loss-free discount calc table. And you can see with this spreadsheet table, it's going to return a double value. The name is loss-free discount calc, and it's passing in information. The parameters has losses and current date is being passed in. So what's going to happen is when we run this, we're going to return the loss-free discount, and it's going to go through different steps, and you'll see that there's a call to the loss-free discount table, which actually is this decision table over here. So that's a great example of calling tables. I'm going to select run. You'll see that we're just not going to put a loss in, it's going to be null, and then it's going to pre-populate with a current date, which is today's date, which is perfectly fine for this example. I select run, and then I get what the return value is going to be, or the result value for this spreadsheet. So there's two examples of spreadsheet types of tables, one that returns a value and one that becomes a matrix of values that you can access. Now we're going to demonstrate how easy it is to use the tracing functionality. So now I'm in a different project in a different module because I just want to show you the trace functionality that you can perform in any type of table that has input parameters, such as a spreadsheet table. So I'm going to actually select, in this example, the driver calculation spreadsheet table. You can see that the spreadsheet table populates, and I'm actually going to use this trace button. So I'm going to select trace, and it's going to then open up a window that I can fill in input parameters around the driver which it's requesting. So I can expand this folder, and then I can fill in the input parameters which are required. That's enough input parameters to run this spreadsheet table. You'll notice down below I can either select trace or trace into file. If I select trace into file, a text file will be saved to my system that I can then view in any type of text editor to read through the trace of this table. And what a trace does is it goes through each calculation step by step and shows you how it came to the different values. So we're going to perform this. I'll select trace. You'll see that a second window opens up. It's good to note that if you have pop-up blockers not allowed through your browser settings, that this won't open. So it might look like the trace functionality doesn't work, but you just might not allow pop-up blockers and the trace functionality opens up via a pop-up. So we have two sides to this window. We have the detailed trace tree side where you'll expand different nodes and folders, and then you have the right hand side where you can view the tables and the different calculations and values and how formulas were resolved. So the first node here is just the table that we have run the trace on. But then you see that each node on the left hand side is associated with a step that we have on the right hand side. So I selected driver, and then there's driver. Then there's driver type, and then there's driver type in the menu over here, and then there's eligibility, and then there's an eligibility step, there's a driver risk step, a driver risk step. So you can see the association with the trace tree to the spreadsheet table that we're running. So I'm actually just going to expand the premium node so we can see the different steps that happen in order to resolve this table. Anytime you see a plus sign, you can keep on hitting the button and expanding. And what you'll see as you keep on doing this are the different conditions that needed to be met, and once you get to a rule that actually returned in true and was the result of the needed step, you can select on it and it'll bring you up to the table, and any rule that is in green is actually the rule that was returned. If you did see red here, that would indicate that a rule failed for some reason. Also, you can use these buttons to configure the colors that you'd like to see the tables in, so you can set them for your preferences. So the trace functionality can be used for unit testing and for any tables that have input parameters that allow you to see how each step and each formula came to its result. And you can do multiple steps here, so you don't actually have to create a test for each step, because this trace functionality can perform that functionality for you. This concludes the demonstration. So now we're going to discuss the test table, which is really kind of cool because we've created all these tables that execute some logic or run some formulas, but the test table is where you can actually create unit tests for your executable tables, such as those decision tables or spreadsheet tables that we talked about. You create this table which calls one of your other tables, but it provides those parameters, those test input values, and checks whether the returned value matches what you've expected, because you will enter in the input values, but you'll also enter into this table the values that you're expected to be returned. So let's take a look at an example. This first one, we see the keyword test. Then we use the name of the table to execute. Down below, I've actually show you that table, and it's a simple rules table that we're going to execute using the values in this test table. So the table is expecting an integer number as its parameter. So you'll see in my test table, our first row is actually that parameter that the table is expecting, and I have lots of values that I'm going to pass through. I'm going to pass through 1, I'm going to pass through 2, I'm going to pass through 3, and when it gets passed through to the simple rules table, it's going to look at condition 1, it's going to look at condition 2, it's going to use the parameters in the order that they're given, and then you'll see the return that is expected and the return that actually occurs. So you created your test table, but you need to run your test table, and you run your test table in WebStudio. So it's really easy to run test tables by just selecting on the test table in the left menu when you're in your module, and then actually selecting the run button that you see. You're going to be brought to a screen which identifies the expected and the unexpected results. So we just went over some of the key tables that you can develop using the OpenL syntax and using WebStudio or Microsoft Excel to create your rules. Now you can go to the OpenL reference documentation, and there you'll see a listing of all the different types of table and the syntax that you need to know, because this was just a foundation.